video. Today I am talking about ESP8266 Wi-Fi module. This is one of the modules which I have been experimenting for last few days. So this took me some time to understand and learn, but here is now what I have got. So you can see that I am not using my usual or Arduino ID. I'm using a new tool called Platform IO. So this is the terminal for the whole Platform IO. Basically, what I am doing is this is the code for what I have achieved. Basically, this is the demo, one of the demo code which you can get in Arduino ID and while downloading the ESP board ESP board manager. So I've just taken from there and just used it for my program. So basically what I'm trying to do here is I am running a web server in the ESP which runs at port 80, and then I am using GPIO2 as the digital pin from which I'll be sending my signals to the LED, and then finally I'm capturing whatever response comes from any web browser, either GPIO 0 or GPIO 1. These 0 1 values basically decides 0 means switch off, 1 is switch on, and then I send the appropriate response. So I have also developed a small program to go along with this. And just to explain how to build in this tool, it's very easy. So basically, you select the platform, you create the code, and then you just go and click on build. Ideally, it should generate the required code, and you can find the code under this PIO environment folder, and the firmware is this is the firmware that we would be using to burn into ESP8266. I'm using a tool called ESP tool.py. I'll just explain on the so ESP tool.py. So this is the handy tool. I suggest you go here and you would get an idea of how to burn into how to burn your firmware into ESP01. I would explain the details of how to do it in my blog. So but just I'll explain you what is it is capable of. So currently I'm just explaining my code that I'm running as a server. So what happens is this: I'm running another code which is a Golang code, which basically will call to that server and would do the switch on and switch off. So this is the code for that. Basically I'm doing if anybody calls to this API, it gives a good UI, and whenever I click the UI, it would switch on or switch off the LED. So the UI part I will show here. If I click on the sorry think go to, so this is the UI. So if I click, this is the UI, and this is the explaining the API part of the GPIO. I've actually already covered how the code would behave. So here, if I click 0, so it will say the GPIO pin is low. It means the GPI 02 is low, and if I click GPIO 1, it will show that GPIO is now high, and the circuitry is sorry. I'll just show the circuitry right now of how it would look like. Second. Just a minute. Maybe I'll just go to so here, just like to show you this is the circuitry I'm using, where on the ground are all see the ground all connects to this USB FDDI converter ground, and then for the 3.3 volt in my FDDI converter I have a 3.3 volt VCC, so I am reusing that. Apart from that, else is same as it looks in the screen. So I hope this is helpful. I'll also follow up with this with my blog post, which would give you a better idea of what I have done and how I did it. Thanks. So here I'm trying to show how the thing operates. So I've clicked, you can see that I've prepared the web app, and from my phone I'm checking it. This is the ESP8266 module, and as how I've connected it on the breadboard. Yeah, you can see that the red light is blinking, and this is the whole setup. That's the LED you can see there. It is much with same as the schematics that I showed earlier in the circuitry. So now if you see, when I'm clicking the red button, it is switching on and off. So basically it goes to the web app, and then from there to the ESP module, where it is switching off and switching on. So I hope this gives you a fair bit of idea of what I have been able to achieve in these past few days.